Hello students, today we are going to study center of mass. It is a point inside or outside a body or object where the complete mass of that body or object can be considered concentrated. How it is so? We will understand that thing by various different examples. At first, let us consider a system of two particles where the particles having the mass m1 and m2 respectively, and the position of that system of particles is such that as given in the figure below. See, in the given figure, a system of two particles has been shown having two mass particles m1 and m2, and both of the mass particles lie along the x-axis at their respective positions with respect to origin, our reference point, at the distance x1 and x2 respectively. The dot between these two masses shows the position of center of mass of this system of two mass particles. But how we can say that the dot position for the center of mass will be in between position of the m1 and m2 masses? For that we can calculate. So here we are consider a system of two mass particles as shown in figure. The position of center of mass is at x distance from the origin, where x equals to m1 x1 plus m2 x2 divided by m1 plus m2, where the mass of the two particles is different. So the x represents the position of center of mass for the system of particles. Now see here, if the masses m1 and m2 have the same magnitude, in that case, if m1 equals to m2 equals to m, say, then x equals to mx1 plus mx2 divided by 2m, which can further be simplified as x1 plus x2 divided by 2. It means that center of mass of a system of two particles having same mass is at the center of their individual positions. Or you can say the center of mass of both particles or that system will lie between the two particles and at the midpoint at the distance between these two particles. If we have n number of mass particles in a system arranged along the x-axis, then the position of center of mass x will be given as m1 x1 plus m2 x2 plus up to the nth terms mn xn divided by m1 plus m2 plus up to the nth term, which can be rewritten further as sigma of mi xi divided by sigma of mi. The term sigma mi represents the complete mass of the system. So we can write this term as sigma mi xi divided by capital M, where the value of M is equal to the sigma mi, the combined mass of the particles as system's mass, total mass of the system. Now if we consider a system where its three particle does not lie in a straight line along the x-axis or along the y or z-axis, in that case the position coordinates of the three particles will be according to their position in an orthogonal coordinate system. So say if the massive particle of that system lie in a plane, then the two directional coordinates will be there to represent their position. So let us take the example for that. If we consider a system of three particles where position of particle is in a plane represented by their position coordinate m1 at the position x1 y1, m2 at the position x2 y2, and m3 at the position x3 at the position x3 y3. Then the center of mass of the system is located at a position xy in the plane. That means the position of the center of mass is the combination of the position represented in two coordinates where its x-axis coordinate position will be given by m1 x1 plus m2 x2 plus m3 x3 divided by m1 plus m2 plus m3, and the position coordinate along y-axis will be equals to m1 y1 plus m2 y2 plus m3 y3 divided by m1 plus m2 plus m3. If the mass of the particle is same, if the mass of all the particles are same, say m, then x will be equals to x1 plus x2 plus x3 divided by 3, and y equals to y1 plus y2 plus y3 divided by, that means that for a system of mass of three particles of same mass, the center of mass of the system is at the centroid of the triangle formed by three mass particles. So that's all for today. In next turn, we will take the general description for the center of mass of a system having n number of particles arranged in a three coordinate system or having their position in a three coordinate system.